Hi, did you know that palm kernel oil extracted from the seeds of the oil palm fruit can be transformed into clean burning biodiesel? In today's video, we explore how chemistry helps turn a local agriculture resource into sustainable energy. Introducing, my name is NURMITHALINA binti KAMAL. What is palm kernel oil? Palm kernel oil, or PKO, is a vegetable oil extracted from the kernel, which is the seeds of the oil palm fruit, Alyas guineaceae. Unlike crude palm oil, which comes from the fruit's mesocarp, PKO comes from the inner nuts. It contains high level of lauric acid and has industrial application in cosmetic, soaps, and increasingly biofuel production. The process is a chemical conversion through transesterification to form biodiesel. Why is it important? In industrial, it used in detergent, cosmetic, and lubricants. It is an affordable fuel and renewable alternative to diesel. In sustainability, it helps reduce reliance on fossil fuels and cuts greenhouse gas emissions. Let's move to the objective of this research. The purpose of this study is to optimize production of biodiesel from palm kernel oil through base catalyzed transesterification process. Next, to evaluate its fuel quality and environmental sustainability. The researchers tested two catalysts, acid and base, and optimized conditions like methanol, reaction time, and temperature to get the best yield. This research relates to fats and oil chemistry because palm kernel oil contains triglyceride, fat molecules made of glycerol and fatty acid. In the transesterification process, these fats are broken down using alcohol and a base catalyst to form fatty acid methyl ester, FAME, also known as biodiesel. This is a common method in oil chemistry to convert natural fats into renewable fuels.
From palm kernel to biodiesel, the process starts with the sample preparation, which is the preparation of palm kernel seeds. First, the palm kernel seeds were thoroughly washed to remove any impurities and then sun-dried to reduce moisture content. Following this, they were carefully deshelled to isolate the valuable kernel. The deshelled kernels were then subjected to mechanical disruption. They were crushed with a mortar and pestle and subsequently blended into a fine and uniform powder. Next is the extraction process. The oil was extracted from palm kernel seeds using a softlet extraction apparatus. In a softlet extraction, 200-gram portions of my samples wrapped in cotton were placed in an extractor with 300 ml of N-hexane and heated to 45 to 60 degrees Celsius, allowing the solvent to repeatedly cycle through the sample to extract compounds which were then dried. After extraction, the crude palm kernel oil undergo base catalyzed transesterification using potassium hydroxide as the catalyst and methanol as the alcohol. This process converts triglycerides in the oil into fatty acid methyl esters, FAME, which is biodiesel. The byproduct glycerol was separated via decantation. Physicochemical properties such as acid value, free fatty acid FFA, saponification value, and moisture content were analyzed to assess oil quality before and after processing. Next is the water washing purification technique. The purpose is to remove residual methanol, catalyst, soap, and glycerol.
Hi, my name is HUSNA binti ABDUL AZIZ. I will present about the result of production of biodiesel from palm kernel oil. The palm kernel oil was extracted using a sourceless extractor. From 1,200 grams of palm kernel flour, 75 ml of oil was obtained. This gives an oil yield of 37.6%, which shows palm kernel is a good oil source for biodiesel production. The physiochemical analysis shows oil has a yellow color, low moisture, meaning it is stable and not easily spoiled. Its acid value and viscosity are acceptable, meaning the oil is safe and smooth enough for processing into biodiesel. GCMS analysis confirmed that palm kernel biodiesel contain mostly saturated fatty acid and fatty acid ester. Fuel properties tests show that most parameters meet ASTM standard except the flash point, which was slightly below the minimum required 130 Celsius. ASTM standard, which are like the rules to make sure fuel is safe and works well in engine. To evaluate the efficiency of conversion, several yield formulas were used. For instance, molecular weight calculation show the average triglyceride in palm kernel oil is about 844.89 grams per mole. This calculation helps determine how efficiently oil converted into biodiesel. I will explain several factors that affect production of biodiesel. First is effect of catalyst. When comparing KOH and NAO, both catalysts produce high yield. However, NAO show better performance at 55 Celsius in just 1 hour, giving a 90% yield. This means that NAO can reduce the reaction time and still provide efficient conversion. Second is effect of temperature. The best biodiesel yield was recorded at 50 Celsius. At this temperature, the reaction proceeds efficiently without significant methanol loss. When the temperature went above 55 Celsius, the yield decreased, likely because the methanol began to evaporate before fully reacting with the oil. Third is effect of missing. The rate of styrene also affected biodiesel production. Increasing the missing speed from 500 rpm to 1500 rpm raised the yield from 90% to 94%. This is because the missing improved the contact between methanol and oil, making the reaction more efficient. Lastly is effect of reaction time. Reaction time plays a key role. When the reaction was extended from 1 hour to 2 hours, biodiesel yield increased. The extra time allows the reaction to complete, converting more triglyceride into biodiesel. Overall, this findings show that biodiesel production is highly affected by temperature, missing, time, and catalyst type. By optimizing this condition, we can improve yield and reduce costs, making palm kernel oil a more efficient and sustainable biodiesel feedstock.
However, despite these advantages, palm kernel oil production comes with serious sustainability concerns. Firstly is deforestation. Deforestation is a major issue. The expansion of oil palm plantations often leads to habitat destruction and contributes to greenhouse gas emissions. Secondly is carbon footprint is another problem. If land use and transport are not managed, sustainable emissions stay high, but with better logistics and energy efficiency, these can be improved. Lastly, with generation. Large-scale production produce excess glycerol, catalyst residues, and other byproducts. Even in biodiesel purification, water washing can lead to massive wastewater, which requires proper treatment to prevent environmental harm. For the conclusion, palm kernel oil is incredibly versatile. It's widely used in everyday products like soap, detergents, cosmetics, and even in food, particularly confectionery fats. Beyond that, it serves industrial roles like in lubricant and surfactants. And interestingly, it's finding a place in renewable energy sector through biofuels like biodiesel. From a green chemistry perspective, PKO supports sustainable innovation. By using enzymatic process, we can reduce chemical waste. Plus, selective processing helps minimize unwanted byproducts. It is also a renewable feedstock, plant-based, biodegradable, and sustainable when managed responsibly. And finally, it's energy efficient. Methods like cold pressing and solvent-free extraction reduce energy use, while heat recovery systems in refining help cut down carbon emission.